All right, number 4, we want to simplify the expression without using a calculator. So we have log base 2 of 4 equals blank. Normally we'll set that equal to x. In order to solve it without a calculator, we need to write it in exponential form. So I'll move the 2 over, and this will become 4 equals 2 to the x power. So 2 to some power equals 4. You can use your power table or think, is there a way that I can rewrite 4 with the base of 2? And I did look up a power table. I have it, so I'll just pull it up. But this is one that we're familiar with. 2 to the second power is equal to 4. So when they say without a calculator, we're going to rewrite it. So this is 2 to the second power is equal to 2 to the x power. Once the bases are the same, we just focus on the top. And so that means x has to equal 2. So that means that this solution is 2. Now, you can solve these with a calculator. You can use them to check. So it depends on the type of calculator you have. There are a change of base formula. Change of base is log of whatever base evaluated at some number is the same as saying log of whatever the valuation is, a, divided by log evaluated at b. And this is understood to be a base 10. Okay, this will work with log or natural log. You could also have a calculator that has an operating system, so like this graphing calculator. Both of them can do this. So if I just type a regular log, it's understood base 10. It doesn't give me an option to change it. So I'll put log of 4, and then I will divide by log of 2. Okay, so this is log base 10 of 4 divided by log base 10 of 2. That's the change of base right here. We get 2. And then with this one we have an operating system. So if I do alpha and I do, I think, window, option number 5 gives me the option to change the base. So I can put a 2 for the base and then a 4. But you can use that property of change of base to still solve it. But either way, we want to write it as exponential and then solve it like so. Number 5, we want to simplify without using a calculator. So first they say let y represent the value of the logarithm, and then we're going to rewrite it in exponential form. Okay. So without doing too much, I'm going to move the 1/3 over. That's going to become my base. So 1/3, instead of the base of the exponential, it's going to be, instead of the base of the log, it's going to be the base of the exponential. And then that will be equal to 81. All right, we got to check. So now we're going to rewrite 81 to the 1/3 power. The way we do that, there's 2 steps that I look at. The 3 can be written as 1/3. It's like 3 to the 1/3 to the -1 power. So since we have the positive 81, I first want to get a base of 3 because of the base of 3 here. So I'm going to go to my power table and see, can I rewrite 81 with the power of 3? 3's, we do. 81 is equal to 3 to the 4th. Okay. So I will start out with 81 is equal to 3 to the 4th. And then to make it 1/3, I will have to move that to the bottom. So this will be 1/3 to the -4th. Now since 1 can be raised to any power without changing it, I can put any power up here. It needs to be the same because we're looking at that on the outside, so I can say a -4 here, and that's just going to still give me 1. So we can rewrite that as 1/3 to the -4th power. Because 1 raised to a power does not change it. So we will put a -4 here. And so that means y equals -4. Also, just again, if you have calculator, you can do change of base. I would just do log of 81, the big number on top, and then divided by log of 1 divided by 3. And you'll still get the -4. You can also do change of base. If I do alpha window and option number 5, and I do my 1/3 and my 81, just showing you some check methods. Okay, see those, and then it says therefore this solution is -4.